Hello, Pekka. Great to have you with us here today. And you're really the champion of this new technology, or we can't maybe call it so new because you've been working on it for more than 10 years. As now as the Chief Technical Officer of Avant Wood, how did you get first involved with the timber technology industry?
Yeah, first of all, Matthias, thank you for inviting me for this interview. I was totally in other industries in managerial positions when I noticed the one startup company and their patent concerning the wood modification, and at that time it was called wood compression drying, and it amazed me because what it did was that a process itself, it dried the timber much faster than the conventional drying, and it could reinforce the mechanical properties of the timber, and I said, wow, I'm now in telecom industry, and they use exactly those lean production principles that this would be also available for timber industry. And mainly that was the reason I got interested of timber, and at that time timber compression drying. And I thought to myself, wow, this is a good idea, but there is also a lot of to be improved and researched and developed in that process so that we could make it commercially viable as well.
That's actually very interesting. So the power of the technology, the functionality, the advantages over conventional drying, and the speed was what really got you so excited that you couldn't resist getting involved. And looking back at the journey, what were the challenges to really get this to a level where it can be commercially viable?
Since I got interested and I studied the process, and then I studied the process control system that were also involved. And quite soon we noticed, me and my team, we noticed that you cannot actually use the conventional process control system in a very fast and short lead time processes. And that's why we got immediately involved also in the control systems development. And then when we got to know the control system development, it opened us new opportunities in improving the total process. When I used the term compression drying, it took maybe a year or two for us that's not only drying, this is wood modification. And therefore we called it Thermo-Mechanical Timber Modification, so TMTM. And then we got the idea of integrating the drying, the densification, so improving the hardness and strength characteristics of timber, and also thermo modification in the same very integrated process. And that was the outcome of that thinking.
Sounds like a bit of a revolution for the industry, right? From very conventional ways of doing it that take a lot of time, and from very fixed ways of production. You have one type of product output and you can't change that unless you make major modifications. Suddenly you have a machine, a technology that can be very agile, quickly adjusting, and maybe you have a lot of different end products that you can make with one of the same core drying and modification process. Is that correct?
Yeah, as I told, one idea led to another, whether it was the process itself or the process control system. And then when we need to make it a tangible project and develop a totally new type of, this time, wood thermomechanical modification unit, there we had a challenge to make it real. And but yeah, that led to our kind of complete integrated commercial version of the product.
What was the underlying motivation for you to really get yourself into such a process that commitment was required? I mean, what's your driving force?
My motivation was only based on my engineering background. So how can you improve the industrial processes that seem to be self-evident? There are several issues. First of all, we can make, we call this TMTM process global solution of wood industry for local challenges. Then I understood that this could be a global solution for timber industry, namely replacing the timber species that are endangered species, tropical hardwood species. We could use some local, sustainably planted and growing timber species instead to eliminate the use of the endangered timber species. Then one thing, very big thing, was that we can use this, especially the small diameter timber, commercially viable and make good products out of them. And by that case, we make a big service to the earth, because then you have an alternative choice to use the small diameter timber not only for burning as energy or for pulp, which will then create a lot of CO2 and greenhouse gases emissions in the atmosphere. That has been maybe the biggest success in the career, because at the same time, simultaneously, the global trend for green transition and eliminating the CO2 emissions and taking it out from the atmosphere. I was told that there is 1,000 billion tons of CO2 in the atmosphere, and our mission is to get it through the photosynthesis to be captured in the trees, not only in the trunks but also in the roots, and keep it there permanently. And then when you have the CO2 in roots, you can cut the timber and then make out of that a sustainably viable end products with TMTM system.
Good. And I mean, if you look at it from a conceptual perspective, what we have here is a carbon capture machine that can turn underutilized small diameter wood that is otherwise usually kind of wasted in carbon capture terms because it's turned into wood pellets or it goes into pulp and paper. We can turn that into long-term carbon sinks by giving it a life of another 50 to 100 years with high-end furniture or building material.